Fine. So if you see this basically, so you have a sprinkler system that is connected to a common valve over here. Similarly, like whenever you've got a sprinkler system, you have to design it with multiple hydrants. As the area is quite big, I have taken multiple options. Now, what should we do? We have to connect our external hydrant to the sprinkler system. You agree? Or pumping, like the entire thing, we have to pump it into this. You agree? So for that
Yeah.
reason, what I would like to do here is I would like to have a sprinkler system at this location. What do you call? We'll have a sprinkler system connection to this guy. So here means parallel to this guy, I can take one more sprinkler line and then connect to this header or not? Yeah, yes or no?
Yes. Yes, we can.
We can obviously. So what I'm going to do is I'll take this line parallel to this guy and then one more line I'll write, which will be connected to from your discharge manifold. Obviously, NRV was over here, so obviously I have to take it in this fashion. In this case, I guess NRV, I can place it internal to the building once it reaches inside the building or in the pump room. Any one of the things is fine for us. So yeah, before NRV, we have to collect it. So let's say this is a sprinkler piping that I'm connecting it. So similarly, what we'll be doing is from here to here also. Wherever the header is there, from the external one, we'll take it. But then I'll have see, in this case, where is the location of a sprinkler system? Just a sec. I guess it's not marked properly. Yeah, this is the location, same location. So from here to here, it's coming. So it's a similar one. Similar one, we have got it over here, right? And then we have a connection to this guy as well. So here we have it. So from this external, so this and this is the same line, right? So this pipe itself will reach above floor and then it will reach till this point and then you have a connection with the sprinkler system. You agree? This diameter will take it as like 150 mm or anything in this case because it's coming from below to above. So according to the number of sprinklers, so we have taken this. Then now what we have to do, we have done this part. Similarly, don't you think this header also have to connect it? So this header, if I try to take it, we have to say, so this header is over here. So this will be connecting it from external one. And here also we have a header. We have to connect it to the external one. Where is the sprinkler piping? Yes, dia is what it is. That is what we have to take. So this is 150 mm dia, 150 mm dia. Okay. So here we have taken it. Just like there is some issue with the pipe size. Just a second. 150 dia, 150 dia, 100 dia is there. So technically, okay. Anyway, we have to adjust the pipe sizes though. So probably I can consider this guy over here as a dropper again. Right, I'll increase this the main branch and now imagine the water is flowing from this direction to the other, like and that's flow. So from here, don't you think I can connect it or not? Pipe sizes I've already showed you in the PPT. It's there clearly as per the hazard. You remember? So ignore this pipe sizes. I'll adjust this pipe sizes. I'll share you the final drawing anyway. Is it fine?
Yeah.
So probably this will be 150 dia, but let's see. Let's figure it out. I got it, the number of sprinklers connected. So similarly, whatever branches are there, those all things we have to. So here also we have a sprinkler system that's connected, right? Uh, this is also external, is it? Just a sec. Here we've got two. This one we didn't connect this guy to. Okay, here we have connected it. We did not connect to this guy over here. I'll just slightly move it. This will connect it to external header. So wherever we have got these external ones on the ground, what we have to show is we have to have a alarm valve. Understood? We will have a alarm valve whenever you have a sprinkler system. Understood? It's mandatory for you to have a alarm valve because in this zone, if there's a sprinkler, it should ring so that everyone will be notified that the sprinkler got broke. Am I clear?
Okay.
Okay, so like that, we have to work on the sprinkler system. Am I clear or not? This you can try it on your own. I'll share you this drawing for the above floor. If you want, you can, of course, almost the layout is same. You might have to adjust the numbers. That's it. Clear?
Okay.
Yeah.
Okay, so from the external ring, we are connecting to hidden system and sprinkler system separately. Hidden system will have a NRV, whereas the sprinkler system will have a alarm valve at the start with an isolation valve, obviously. Clear?
Yeah.
And from the terrace to any to hidden system, we have to loop all the internal hidden system into a single one, and then we have to connect because everywhere we have got NRV alva. So we have to connect all these things to a common tank system. Yeah. So we'll keep a tank over here, and then from the tank, we will connect to all the internal pipings. I'll just show you this one. Just a sec. Not the sprinkler. It will be a hidden system anyway. Say, hope. Yeah, hidden system. Let's say this is our syntax tank. We have placed it anywhere over here. Let's take it this location. I've placed hidden valve. For all the hidden system, of course, whatever the hidens are there, that circle also you have to show it, obviously. Okay, then what you have to do, you have to connect all these hydrants to a terrace piping. Of course, you will take peripheral, but as of now, as we're not constructing here, I'm just showing you. So we take peripheral so that it is not obstructing people's path. Clear? Understood?
Yes, sir.
Yes, sir.
So we'll connect it to the hydrant system. So all the hydrant on the terrace should be connected to your terrace, nothing else. I'll share you some couple of drawings so that you can go through the entire drawing for you to understand all the sprinkler system and all how do we do it. Clear? And if necessary, we have to install a pump. So that is nothing but your booster pump. Okay. So that is how you have to basically design your sprinkler. So it's a basic concept I've taught you using IS code. So using that, you will do our drafting, nothing else. And the drain portion, we have two options of doing the drain, which I wanted to illustrate it here. Let's take this is your main standpipe. One option is you have your main branch, you have your feed main like this, then you have got a branch to this, you have your sprinkler system. You agree? I'm just drawing an isometric view, right? So like this, we'll have multiple branches across the system network. You agree? So one of the options, one of the things that we do it here is it's mandatory for us to install, I mean, in every zone, I would say it's my alarm valve anyway. See, I'll just explain the schematic because every component I didn't show in the drawing, so I just wanted to show it away. Let's take this is multiple floors we have it. Okay. Then what we do is at this location, whenever you have it, first and foremost thing is whenever you're connected to external hydrant or anything, here you will have a alarm valve. This alarm valve will tell you, yes, this entire razor, some of the any of the sprinkler got broke. But don't you think I have to connect it to the PA system or anything? Yes or
Yes,
no?
it has to be connected.
Obviously, I have to tell everyone that there's a fire in the building, please escape. So for that reason, we have a flow switch in, and we'll obviously know which floor or which zone it is also. For that reason, we have a flow switch in every line. We have a flow switch here. We'll have a flow switch at this location. Am I clear? So at this location, we have a flow switch. At all these locations, we have a flow switch. Understood? So we'll have a flow switch which will be integrated to the fire alarm system. In depth, we'll have a discussion on fire alarm system, including all the components. Don't worry. So now coming to the drain point. So you can either have a drain at this location. I'll change it to other color, let's say. Yeah, you can have a drain to drain something like this. So from here, you will take a one more header, which is your drain portion. Which is your drain portion, you will take it. And you'll have an isolator valve, obviously. You'll have your isolator valve, which will be connected to this again.
What's the purpose of this drain point, sir?
I'll tell you. I'll tell you. Okay, two things. The reason why you require drain. Okay. First and foremost, let's say sprinkler got broke. It could be accident or it could be because of fire. You agree? So if it is accidental, is it okay to flood your entire space with water and screw up your furniture,
Mm,
like everything?
no, no, not okay.
No. For that reason, what we do is the sprinkler will be like, dummied. If you have any damage, you remove the sprinkler, you do it. But whatever it is, first of all, what will you do is you'll basically open, so you'll have a isolation valves here. You have your isolation valves here. You have a isolation valve at this location. Okay. You'll have isolation valve here. You'll have isolation valve at this location as well.
Okay.
At this you have isolation, this you have isolation. So what will you do is basically, sorry, at this location, sorry. Before this you'll have, before this drain, you'll have your isolation at the particular flow. So whenever the sprinkler broke accidentally, what will you do? You close this isolation valve so that fresh water doesn't come in, and whatever the water is there, instead of here, you want more water to come through this so that you can drain it off. That's number one.
Okay.
Number
The
two,
water which is
late
already in the pipe that is going
pipe,
to
you
come
are
back.
come back. Yes. I mean, some pipe, some water will come, but not entire water now need not come through the broken sprinkler, right? Because you provide an
Mm,
alternate option. So 60%, because the diameter of the pipe is also more. So around 60%, 70% of the water will come through this particular one. So that your flooding volume will reduce. You agree?
mm.
Yes.
Yes, sir.
Number one. Number two is at many locations, say for example, you might have given future tap-offs.
Mm,
For example, in few areas, okay, let's say builder's perspective. As a builder, we have done above sprinklers we have provided. Below sprinklers, I do not because, later the concessionaire will come and he'll have a false ceiling and he'll plan his sprinklers. Right or not? So
mm.
when I do that particular exercise also, I'll just provide roof sprinklers. Below that, I'll just provide provisions. Then what should I do? They have to remove they have to remove our sprinkler pipings and then we'll install your flexible pipes. I'll just show you how generally we have, because recently we had some couple of things. What's his name? Side. So generally, when you see a builder, you'll have a provision like this that we'll be providing it. Then means above roof sprinkler, you will provide it like this. Okay. But
Okay.
below ceiling sprinklers, if you do it, you will provide only with dummies. You can't see a sprinkler over here. It's just a plumbing dummy. You could say it over here.
Yes, sir.
Yes, sir.
Then what will we do? We'll open the valve, we'll drain the entire water, and then we connect it to the flexible pipes so that later on, when the fall ceiling comes, we'll connect it like this. So afterwards, we'll make it something like this. Understood? So for that reason also, don't you think you require drain?
Yes, sir. We require.
Yes.
Yes. So for those all reasons, so for future expansions or if there's any leakage, if you want to remove water for all those things, we require this drain pipes.
Then
Clear?
where this sprinkler drain is connected to the external drain or again to some.
No, not to extend, not to sump again because it's a rare application and the water will be bloody dark, I mean, because the water is stored in the MS pipe. And once you open it, you'll get like, the black color water. So you don't mix it, you push it either to rainwater or to whatever is available, nearest available for you, either to stormwater drain or normal regular drainage.
Okay.
Okay,
Yeah.
that's how we basically connect it. Understood? So along with that, generally we have your hydrant drains also. That also, if possible, we'll connect it to this gate itself. Generally, when you have your hydrants, okay, let's say you've got a hydrant valve. So from the hydrant valve, generally what will happen is, I'll just explain you here. So this is your hydrant valve. So when you have a hydrant valve, there might be some leakage later, or you might have opened it. So for that reason, we generally provide a flow drain. Plumbing consultant will provide it's not mandatory or it's not a rule, will provide a flow drain. So generally your hydrant main and your sprinkler main will be running parallel to each other. Understood? So for that
Yes.
reason, what we'll do, this drain and that drain also, will combine it. I'll just explain you here. Let's say this is each floor. Show you with other color, let's say. Let's say this is your yard hydrant. This is at ceiling level. Yard hydrant, we have it at 1.2 meters level. You agree? Similarly, you have your hydrant valve. Okay, in all the three floors, you'll have your hydrant valve. So when you have a hydrant valve, automatically what will happen? Near the hydrant, you will provide a small flow drain provision. Okay. So from the flow drain also, you'll connect it to your this one. So one more drain provision, you will connect it to the floor level, near the floor level, beneath the yard hydrant location. So that drain and this drain also you can combine. There's nothing wrong with that. Am I clear?
Yes, sir.
Okay, of course, we provide with a Y joint. We'll generally provide. So if this is your, I mean, you're already a plumbing expert, so I need to explain you. It'll be connected like this one. So using a Y joint or anything, we'll connect it to your main drain pipe that's coming down. So this is your flow drain, and over the top you'll have your sprinkler drain connection. This is your sprinkler
But
drain connection. This
the
might be a
most of
sprinkler
the
drain.
times that hydrant drain will be separate only, right?
Need not be. That's what you can connect sprinkler drain and this drain also together. There's nothing wrong if you do not connect it. I mean, if you can
Okay.
connect, you can connect. There's nothing wrong with that. That's what I meant to say. It's
Mm,
after the drain point.
Done, done.
Yeah.
Yes, sir.
Okay. So any queries still now?
Yeah, noted, sir.
No, sir.
Continue.
Okay, fine. The only thing is you have to be very careful. You have to give a very bigger diameter because when the water comes through this pressure, water should not come out through the flow drain again because it's pressurized water that's coming in this drain. Yeah.
Yes,
So
sir.
your Y interceptions, all those things will be, but you have to give better Y answer. Anyway, so this is a short note on your sprinkler system and hydrant system. But for this building, don't you think we are yet to give something called as your this one fire brigade connections? Yes or no?
Yes.
Yes, sir.
So we have to provide your fire brigade connection and a drought connections as well. So if you consider fire brigade connection and drought connection, we have to provide brigade connection at two locations. One is directly to the ring main, and second is to your tank. You agree?
Yes, sir.
So we have to provide to external yard hydrant, and you have to provide even to your tank as well. So if you want external, so wherever the entry is the nearest entry point, you will take a stub and you will take it from the top. So I'll just show you here. I'll mark it with other color. Let's say yellow. So you'll have your four-way head, like your header valve over here. You will have your yard hydrant at this location. One is at this location you'll have it, and other one is you have to locate it near your tank. So tank means obviously it has to come through this location in this case. So we'll draw two pipes over here. One is for drought connection, one is for yard hydrant. So you will take one more pipe at a higher level, obviously. Which can go in this fashion, and then you have a hydrant valve over here. This particular pipe will come to the top, so it can probably come near a sprinkler wherever it has come. Where did this guy come in the first place? Yeah, at this location, Alva. So here we might have a one more valve, which is our this one. So from here we'll have one more valve. I mean, I have to give a direct outside access. So I'm providing this as your yard hydrant. Am I clear? So from external, you have a yard hydrant over here, which can basically connect it to, like, through the system. We can pour water directly into your tank. You agree? But only thing is you should have a 6 meters width so that vehicle can come in. Clear?
Yeah.
And second thing is we have to give even drought connection as well. So that I'll with see or anything. So we'll have one more connection, which is your drought connection. Similarly,
Sir, this fire brigade inlet, one is near the sump and one is near the entry. Entry to the
the,
site
the
or entry to
entry
the
is
building, sir?
directly to the piping system. That means you can pump water directly into your hydrant system, like your external ring main, so that water can enter into your hydrant or your sprinkler system.
Okay. No, the thing
From this
is,
one, yes,
the thing is, I'm asking, it can be anywhere near the hydrant, right? Then,
yes, yes, yes. It can be near anywhere near the system. Anywhere near the hydrant in the sense, it should be accessible externally easily. That's it.
okay. The feasible is entry only then.
Yeah, yeah. Right, right. Obviously, because it
Okay.
will come near the entry, right? So it's easy. That's it. It's no rules as such. But as per NFPA, if you see, as per the building dimension, they'll ask for two, which is oppositely diagonal into the ring main directly.
Okay.
If the plot area is so and so as per NFPA, then according to this, length of area of your building, if more than one also might be required. So in that case, diagonally opposite is what you have to provide, two numbers into the ring main.
Yeah.
That is as per NFPA, but not as per NBC though,
Okay.
or not as per IS codes. Okay. So this
Yes.
particular ring main will be coming over here. Let's say I'll just move this guy slightly. So we have one more piping that will be connected to your foot valve. This will be connected to your foot valve of the floor, and from here you will directly connect it to this location. So this pipe is connected to this guy. So from here we are able to draw the water from your tank. So here we have your foot valve. Understood?
Yes, sir.
So this is the final layer. So I'm not going in depth into the piping, drafting and all, which is probably not required at all. Hope this is clear.
Sir, this
Madhu, yes, please.
diameter for this drought and inlet connection will be standard, no?
Yeah, it will be standard of
Right.
150 mm dia is what we use it.
Okay.
Right. So any queries you guys have?
No, sir.
So what about you, Madhu? Are you I mean, till now it's clear?
Yeah.
So with this, we'll conclude the basic project on this because I don't want to spend time, especially at the project. Uh, this particular project where we had a discussion because we have a lot of other information that we have to understand. Okay, so shall we go further?
Yes, sir.
Okay. So whenever you work on a particular one, whenever you work on a particular project, okay, so always remember you have to understand, you have first and foremost thing is the requirement is really important. So as the project is small, we have gone for only one sprinkler system. What if you have a bigger project where you require sprinkler pump as well as hydrant pump? So in that particular case, we have basically sprinkler pump and hydrant pump, and we should have a special arrangement inside your pump room, which I'll be illustrating you now. Can I close this guy?
Yeah.
I'll share you the completed projects, not this one. So any other projects, I'll just show you. I'll make you go through, or I'll share the projects so over WhatsApp. You can go through them, and if you have any queries, you're always welcome to ask me. Okay. Uh, I'll open one more drawing layout just to explain you on the project, pumping systems. And then today we will complete entire water-based firefighting systems. So now we'll have a discussion finally on our different pump schematic. Now we have learned only one pump schematic which has both sprinkler and
Hydrant.
hydrant is only single pump. But now we'll understand a schematic which will have separate like both the hydrant and sprinkler pumps which are separate. Am I clear?
Yes, sir.
Yes.
So when you have your hydrant pump and sprinkler pump which are separate, let's say this is your tank anyway. From the tank, we basically have your sorry, one line. What? 25. Okay, the tank. This one is pretty huge, is it? Okay. So you will have your suction manifold, which is common to both the tanks, right? So when you connect suction manifold to both the tanks, so here you'll have a strainer. I mean, if it's up to you, for every pump also you can place it, or directly at these two manifolds also you can place your strainer. Nothing wrong with that. Understood? So you can have a strainer at this location, and at this location also you can have your strainer. Yeah. And then you have a sluice valve or isolation valve. Of course, you'll have it. First, you'll have your isolation valve, your IV, you'll have it, and after that, you'll have your sluice valve. That's common, whatever the pump network we are speaking about. Okay. And from here, we will connect it to four different pumps, which will be clearly given in NBC as per notes if you see. Okay. For Vivigo project, you'll have it. After this, I'll just show you any of the notes, you'll understand it. Okay. So generally what you have is you have the following arrangement. You have the following arrangements. You have four pumps. First one is your jockey pump. I mean, arrangement could alter. I'll explain you that as well. This could be your like your regular pump, electrical pump or anything. This could be your jockey pump. And then you might have a diesel pump. And then you might again have your one more electrical pump. Okay, it could be any of the order, but only one specific requirement is mandatory. So let's say this is your discharge manifold. So when you have it over here, so I'll just write the text. This might be sprinkler pump. This could be your sprinkler pump. This could be your, okay. This is your sprinkler pump. This is your jockey pump. This could be your, what is it, diesel pump. And this could be your hydrant pump. So when you have these pumps over here, you can have sprinkler, jockey, diesel, and hydrant pump. So out of these pumps, when you have it, these three arrangement could be any of the things. There's nothing wrong with that. But sprinkler pump should always be at the end, either left corner or right corner for a specific reason. So here, when you have like this other valves, I'm not explaining. You guys are already aware, like your flexible bellows, butterfly valve, and RV, all those things. So I'm not going through all those things. Additional valves only is what I'm teaching you. Is that fine?
Yes,
General
sir.
requirement. Now, this is suction manifold. This particular guy, we call it as suction manifold. This is your suction manifold. And then this is your discharge manifold. This guy is your discharge manifold. This entire header, this line and that line. Okay. So from the discharge manifold, when you have a sprinkler pump, you should have a NRV at this location. Okay. You'll have a NRV at this location, which will allow the water, it can allow the water in this direction. Just a second. Hmm. So, which can allow water in this direction, but doesn't allow the water in the opposite direction. Okay. So, which means your hydrant water can enter into your sprinkler system, but your sprinkler system water cannot enter into your hydrant system. Clear?
Yes.
Because manually, once the firefighters comes into picture, anyway they will be able to switch off the sprinkler pump and entire water will be used for hydrant system. But until fire rescue comes into picture, your sprinkler plays a major role. You agree? So for that reason, it's mandatory for the water to flow through this to the sprinkler system, but not to the hydrant system. So from here, you will take a tap of this to your sprinklers network, and this you will give it to your hydrant network. This is to sprinkler system. This is to hydrant network. Am I clear?
Yes.
Understood or not?
Yes.
So from this one, you will again connect it to your pressure vessel. So you'll have a pressure vessel at this location, so that you don't have any fluctuations. Here also you'll have a pressure vessel. And obviously from this outlet and this outlet, you will connect it to one more manifold in which you'll have your pressure switches, which will basically switch on and switch off automatically according to the pressure requirements. Understood? So your sprinkler pump, all the pumps will be automatically on, but only your jockey pump will be automatic off. Rest all is manual off only. Understood? Well, this we already had a discussion, if you remember. Did you understand the second schematic or not?
Chaitanya, can you look
Yes.
at the pressure, where it will be? Like,
Okay, pressure switches. You can take anywhere. There's no rule as such. So basically, what we'll do is we'll take one more. Change it to the other color. So from here, you'll take small piping. From here also, you will take a small tap off. Okay. I mean, any room corner or anywhere will basically take it. Okay, don't worry. So let's take something like this. A small 25 mm pipe is also sufficient for this. So here, what will you do is we'll have a piping in this particular connection. One more small, like, probably a 50 mm pipe or a 100 mm pipe, it's up to you. And then you have a small separation also in between. So here you'll have a pressure switches. So here you have for sprinkler pump, here you have your hydrant pump, and then you have got your jockey pump, and then you have got your hydrant pump. This particular manifold will give you these three, and only for sprinkler you'll have this pressure switch. Understood? Am I clear?
one more doubt, Chaitanya. Why do you want three?
Yeah, but we've got because we have to switch on the pump separately, right? So from a single switch, how can you connect it to different starter panels?
But what is coming from the delivery to the switches are only one pipe. In that, you have to manage, is it? How is it?
See, one pipe is coming, one pipe is getting connected to this. So whatever the pressure is inside this pipe, the same pipe pressure will be reflecting in this zone, right? Here there's a separator, I said. So you can actually keep it at separate location also. But generally we make everything at the same location. That's it. For the ease of access.
Okay, from this, okay, understood. Based on the
That's a
pressure,
separate, it's a separate pipe, this is a separate pipe. And you'll provide a drain provision over here. Here also you'll provide a drain provision, here also you'll provide a drain provision. Understood? Still have some query? Yeah. So this is your drain provision. This is your drain provision that we provided. Yeah.
Actually,
So
one more
yes.
doubt. Based on this, wherever we have got three pressure switches now, there based on pressure only, it goes to their own, to the particular pump, is it?
Yes. So from the pressure switch, you have a setting of switching on and off. So you have a start point, differential pressure. Your differential pressure switch is what you use it. So the minute there is a pressure difference, automatically the pump will on. So you will set the value. Say for example, you want the pump to be on at 8 kgs per this thing. So what you do, 8 kgs, you will basically keep that particular one. Off, you don't have any setting anyway, so you need not worry.
Okay.
But whereas for jockey pump, okay, I'll just write the numbers also so that it will be easier. Generally, this will be the case that we do it. So generally, if this is jockey, hydrant, sprinkler, and then you have got your booster. There's a diesel, then booster pump. So generally, if you take your jockey pump will be on at first, it will only on. Let's say 7 or 8 kgs. Okay, this is on. Whereas it will be off at 7 kgs. Understood?
Okay.
This is on point, this is off point. Whereas your hydrant will be on probably at 6 kgs. And your sprinkler could be made at 0.5 difference or anything. You can keep it. It's up to you. You can take it as 5.5 or 5.8 or anything. It could be 6 also. There's nothing wrong because both are separate systems altogether. Then you have got your diesel. Diesel, when this fails, then you will use probably somewhere around 5 or 4.5 kgs. kg per centimeter square, what I meant to say is. And then booster pump will be made at the lowest one, which is probably 3.5 or something. Yeah. Kgs per centimeter square here, the unit charge. So basically, how does it work is kg per 25, and then again, it will be off at, it will be off at 2.5. Booster could be on it again, off at 3.5 kgs. So basically, what will happen is when you take these particular values over here, your jockey pump will initially run. When there's a minor leakage, first your jockey pump will run. So if because generally your pressure will be 9 kgs or anything, so 1 kg drop you will give a tolerance, and once it starts, then your jockey pump will start running. So once jockey pumps is running, then your flow rate is also lesser, like your internal hose still drum or anything. If you are using it, that flow rate will match, so you will not have any apparent pressure drop. Understood? But let's say the flow rate is lower now. There is a hydrant valve or probably more sprinklers have broken. So automatically, compared to your flow rate of your jockey will be lesser. It will be 180 LPM or anything. But whereas for your sprinkler pump and hydrant pump, the flow rates are higher, alva. Yes or no? We have calculated it already, if you remember. According to the number of hydrants, as per IS codes, we have to carry. When you take the particular values, and what will happen? Your flow rate of your hydrant is way higher. Then once your hydrant pump have started, let's say, but your jockey pump is still not on, then your jockey pump is running, even then your hydrant pump have started. So your hydrant discharge will be how much? Say the flow rate 2880 LPM or whatever it is. So automatically, I don't think the pressure will build up or not inside the system.
Yes.
Yes. So then what will happen? The pressure. So automatically the pressure will cross. Sorry, this is slightly. Just a sec. It will start at 7. It will start at 7. It can stop at 8. Sorry for that. Because start point should be lesser than your stop point. Okay, then what will happen when the pressure drops below 8, below when the pressure increases, then suddenly the jockey will stop again. Understood? Am I clear?
Yeah.
Okay, then if your hydrant system is working, it's fine. Let's say more sprinklers broke. Then the pressure gauge is there at sprinkler piping, alva. So it will measure only sprinkler system. So then sprinkler pump will also start. Understood? If both the system fails, then the pressure will further drop, and then you have your diesel. If diesel is also unable to take it, the last picture that will be helping you is your booster pump. Understood? That will only be for your internal hydrants. Am I clear or not? So only jockey and booster will have automatic on and off. Rest all will be manual, automatic on and manual off. Clear?
Yeah.
Okay. So these are the sequence of. Along with that, inside your pump room, you have to even provide something called as a test point and PRV. So you have to provide something called as a test point because every time you will not open hydrant and you can see, right? So for that reason, we have one more line, which is your test point. So you'll have one more line, which is connected at this location, which will be connected back to your tank. This will directly be connected back to your tank. Okay. So though it is there, it's not connected. Only this is tap of location and this is tap of location. This will be your test points, test manifold. Yeah. So this test manifold, how does it work is simple. So here you'll have an isolation valve. Here you have an isolation valve. So when you want to test the sprinkler system, you'll switch on this butterfly valve. So automatically, because water will flow into your tank, back to the tank again. Then you can see, you can simulate as if the sprinkler got broke. Understood? Similarly, you will have it at this location also. Similarly, you have for your hydrant system also. Because instead of opening and draining the room space, you can open the valve over here and test whether the system is working or not. Understood? Hello?
Yeah.
Able to follow or
Sir,
not?
yeah.
Yes, tell.
Sir, what if the pressure drops in the pipe, sir?
Means I didn't understand your question. Can you come again? I mean, pressure drops means what if in the sense? For what reasons the pressure will be off? Then I can explain you the
Sir,
impact of that.
the point is, see, for flow rate at the flow rate, sir, uh, in the pipe, the meanwhile the constant water will be the water will be constant, right, in the pipe.
The water will be always be pressurized. Yes. The entire
Yeah,
system is always pressurized at 9 kgs or 8.5 kgs, whatever it is.
uh, at certain time that will drop, no, sir.
Why will it drop unless there's a leakages?
Okay,
If
without
it
leakages,
drops
it will
because
be
of temperature, or you can say like because of the temperature, there's not much impact. Then what will happen? At max, your booster pump will again run. That's it for some time. Again, it will be off automatically.
okay. Okay, it will fulfill the pressure again.
It will fulfill the pressure. Your booster pump, your jockey pump is anyway there to do that activity, alva.
Okay, okay, got it.
And not only that, you have a pressure vessel. So pressure vessels also will also like your hydromatic system, it will cater to certain demand,
Okay,
right? Okay.
yes.
Then in the testing manifold, it's mandatory for you to provide something called as a flow meter. We'll provide a manual flow meter. Okay, actually, flow meter will be expensive. So instead of flow meter, generally what we'll do is water meter will directly place it. Water meter, because at the end of the day, I have to know the flow. When I want to test it, I'll note the start timing. I'll note the end timing. So I know the value, and then we already know the water meter. We'll know how much cubic meter of volume have gone. So divided by time, if I do it, don't you think I'll come to know the flow rate?
Yeah. Yes.
So because flow meter is expensive, that's the reason as a cheap, though consultant provides us as flow meter as a builder will try to use water meter itself. Understood? Am I clear? So you can propose water meter as a, because most of the consultants what they do is when I was working as a consultant, I used to give as a flow meter. But yeah, even maintenance team says even water meter also be chalega. So water meter is way cheaper than your flow meter. So we'll go for water meter in most of the cases. Understood?
Yes.
Clear?
Yes.
The last point is we have to have a pressure relief valve in your discharge line. So we have a pressure relief valve. So we will install something called as a pressure relief valve into your tank again, which we call it as a PRV. The reason why we provide a PRV is simple. Then let's say the flow rate requirement is 500 GPM or 600 GPM, but your pump is continuously running. So when your pump is continuously running, then you're not switching off. Let's say accidentally you have switched off the hydrant valve without switching off your pump. So your continuously pump is running. Then two cases can happen. One thing, so you do not have any outlet or sufficient outflow is not there, but your pump is continuously running. So what will happen? Pressure inside the system will increase or not? Right, so that can cause two things. So one thing is, of course, nothing major will happen, but the first thing that can happen there is basically your your pump discharge pressure will continuously increase, which results in your increase of your current consumption. So you'll have a breaker inside your system because of overloading. The automatically the starter panel that will be off. Clear? What if it is not off? So if it is not off, then your motor will burn. So to protect, like a MCB in your electrical system, like your overload relay, whatever you place it. Similarly, we place a PRV over here. You can keep cages or 9 or anything, so that in case if the volume is lesser than that, your from the PRV water will again go back to the tank. The excess water will go into your tank. Understood? We'll have a PRV over here. Am I clear or not?
Yes.
So, from the discharge manifold, you'll have a PRV again to your tank system. So that's a general arrangement in your pump room. Clear or not? Okay. So this is one arrangement. Second arrangement, what I've taught you is inside the project, it's only one electrical pump, one diesel pump. All the things will be there. Only thing is, instead of two electrical pump, there'll be one electrical pump, and there won't be an NRV over here. Rest all test manifold, all those things are mandatory. Yeah.
Diesel tank.
Which one? Diesel tank will be there near your diesel engine. That's it, alva.
ಹೌದು ಅದ್ರ ಕೆಪಾಸಿಟಿ ಹೆಂಗ್ ಡಿಸೈನ್ ಮಾಡ್ತೀರಾ?
You have to take 2 hours of its running time. You should have the capacity. So it depends on the efficiency of the diesel, right? So like minimum 2 hours is what you have to store inside your tank.
Storage capacity 2 hours. Okay.
2 hours. That is also there in the IS code. I'll share you a screenshot of that. That is also clearly mentioned. According to your hazard, is it 2 hours or 3 hours? It's mentioned. General 99% of the cases, 2 hours should be sufficient. Understood?
Yeah.
Anyway, it's there in the IS code and high range. If you see in that, it's clearly given for diesel.
ಡೀಸೆಲ್ ಇಂಜಿನ್ ಎಕ್ಸಾಸ್ಟ್ ತಗೊಂಡು ಆಚೆ ಬಿಡಬೇಕಲ್ಲ ಒಂದ್ ಕಡೆ ಎಕ್ಸಾಸ್ಟ್ ಡೀಸೆಲ್ ಎಕ್ಸಾಸ್ಟ್ ತಗೊಂಡು
diesel engine exhaust also you have to place it. So from the diesel engine, you will take exhaust and you'll keep it externally. That's it. I mean, you'll take a silencer with that particular pipe, it will take it, and generally it will be 80 mm dia or 100 mm dia. Worst case is 150 max. So that particular pipe you take it out and then you give it outside. That's it. Even if you have anything, about 3 meters.
ಅದಕ್ಕೆ ನಂಬರ್ ಬೆಂಚ್ ಇದೆಯಾ ಎಕ್ಸಾಸ್ಟ್ಗೆ ಅಥವಾ ರೆಸ್ಟ್ರಿಕ್ಟ್ ಮಾಡಬೇಕಾದ?
Try to avoid maximum number, but as such around 4 or 5 we have given till now and we have never faced any problem as such. So it's better we speak to the OEM of the diesel engine.
Okay.
There's no such rule. It depends on the capacity and the brand as well. So yeah, that we have to speak to the OEM, but generally 3. Now my previous project also, because once you raise it, anyway you have to take right or left. One we have taken second. Around 4 vents we had to take. Yeah, it's functioning fine. We never faced any issue. That's it. So if you have a doubt of that, you increase the diameter of the pipe so that you'll have a lesser impact of pressure, back pressure.
Okay.
Understood? So with this, we have completed our water-based firefighting system. So you have any queries? You're free to ask me.
ಚೆಕ್ನ ಇನ್ನೊಂದು ಲೈಕ್ 16 ಫ್ಲೋರ್ಸ್ 24 ಫ್ಲೋರ್ಸ್ಗೆ ಸ್ಕಿಮ್ಯಾಟಿಕ್ ಮಾಡಿದ್ರೆ ಅವಾಗ ಲೈಕ್ ನಾವು ಪ್ಲಂಬಿಂಗ್ ಅಲ್ಲಿ ವಿ ಡೂ ಝೋನಿಂಗ್ ಅಲ್ವಾ, ಅದೇ ತರ ಇದ್ರಲ್ಲೂ ಝೋನಿಂಗ್ ಬರುತ್ತಾ? ಯಾವ ತರ ಸಿಸ್ಟಮ್ ಇರುತ್ತೆ? ಲೈಕ್ ಸಪೋಸ್
one zone you can't have more than certain square feet. Sprinkler system.
ಎಷ್ಟು ಒಂದ್ ಝೋನ್ ಎಷ್ಟು?
Like according to the type of hazard, you have this 100 not more than 30,000 square feet or 42,000 square feet, 4,000 square meters in a particular zone.
Sir,
Remember, there is a light hazard, ordinary hazard, extra hazard. In light and ordinary, around 4,200 and 3,500 for extra hazard. So more than that particular square meter, square meters, if you have it, you should consider it as a separate zone altogether.
ಚೈತನ್ಯ ಅದನ್ನ ಹೇಳ್ತಲ್ಲ, ಅದನ್ನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ರಿ ನೀವು. ಇನ್ ದ ಶಾಫ್ಟ್, ಸಪೋಸ್ ದೇರ್ ಇಸ್ ಹೈ-ರೈಸ್ ಬಿಲ್ಡಿಂಗ್ ಆಫ್ 30 floors. ಪಂಪ್ ರೂಮ್ ಇಂದ ಬರೋ ಸ್ಪ್ರಿಂಕ್ಲರ್ ಪೈಪಿಂಗ್, ಹಾರ್ಡೆಂಡ್ ಪೈಪಿಂಗ್ ನಾವು ರನ್ ಮಾಡಿದಾಗ ಶಾಫ್ಟ್ ಅಲ್ಲಿ ಫಾರ್ 30 floors, pipe throughout from the ground to the terrace level, how is it?
You will have one pipe only, but the thing is, you might not connect you might not connect all the pipes to a. I'll just explain. I'll just make a sketch over here, then it will be clear.
See, we're using this MSMO pump idella. Multi-stage, multi-outlet.
Right.
ಸೊ ಅದನ್ನ ಹೆಂಗ್ ಅಪ್ಲೈ ಮಾಡೋದು ಅಂತ ನಂಗೆ ಅದೇ, ಲೈಕ್ ಶಾಫ್ಟ್ ಅಲ್ಲಿ ಏನಾದ್ರು ಲೈಕ್ 2 ಸ್ಪ್ರಿಂಕ್ಲರ್ ಪಂಪ್ ಪೈಪಿಂಗ್ ಯೂಸ್ ಮಾಡ್ಬೇಕಾ ಅಥವಾ ಈ ತರ ಅಂತ?
See, for I didn't understand, sorry. English, Kannada, ಸ್ವಲ್ಪ ಗೊತ್ತು, ಅಷ್ಟು ಜಾಸ್ತಿ ಇಲ್ಲ, but okay, I can manage. Please tell me.
See, I'm sorry. What I'm saying, sprinkler. See, I have to take a sprinkler piping in my shaft for 30. Suppose we are doing 30-story building.
Right. Okay.
For all 30 floors, you'll take one pipe from the ground to 30th floor. How do you?
No, when you take it as a separate zone, then obviously you will have to consider it as a separate line altogether. So what will happen in that case? For probably you might have to take. I'll just change the color of this. Just a sec. So let's say I might have considered something like this. Okay, these 4 floors I might connect through this piping until it reaches the 3,000 square meters. Okay, and remaining we may take from other particular pipe. That's what I've told. Like one zone cannot be more than that. Understood or not? But everything will be connected to a common pump room. Just a second. It is crying. Just a second. Just give me a minute.
ಪ್ರೇಮ್,
ಸರ್ ಹೇಳಿ ಸರ್.
ಇದ್ರಿಗೂ ನಾನು ಏನ್ ಕೇಳಿದೆ ಅರ್ಥ ಆಯ್ತಾ?
ಗೊತ್ತಾಯ್ತು ಸರ್. ಪಂಪಿಂಗ್ ಅಲ್ಲಿ ಲೈಕ್ ಪ್ರೆಷರ್ ವೈಸ್ ಝೋನಿಂಗ್ ಮಾಡೋ ತರ.
ಇವಾಗ ಹಂಗ್ ನೋಡಕ್ ಹೋದ್ರೆ ಇವಾಗ 30 ಫ್ಲೋರ್ಗೆ ನಮ್ಗೆ ಸಾಕಾಗುತ್ತಾ ಅಂತ ಸ್ಪೇಸ್ ಶಾಫ್ಟ್ ಅಲ್ಲಿ?
ದಟ್ಸ್ ವಾಟ್ ಸರ್, ನನ್ನ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಅದೇ ಇತ್ತು. ಅರೇಂಜ್ಮೆಂಟ್ ಆಫ್ ಶಾಫ್ಟ್ ಹೆಂಗಿರ್ಬೇಕು ಮತ್ತೆ ಸ್ಪೇಸ್ ಹೆಂಗಿರ್ಬೇಕು?
ಓಕೆ ಓಕೆ.
ಸೊ ಇವಾಗ ಇವರು ಝೋನಿಂಗ್ ಅಂತ ಹೇಳ್ತಿರೋದು ಹೌದು. ಸೊ ಈ ಹಜಾರ್ಡ್ಗೆ ಇಷ್ಟು ಸ್ಕ್ವೇರ್ ಮೀಟರ್ಗೆ ವಿ ಆರ್ ಡಿಸೈನಿಂಗ್, ರೈಟ್? ಇಷ್ಟು ಫ್ಲೋ ರೇಟಿಗೆ ವಿ ಆರ್ ಡಿಸೈನಿಂಗ್ ಆರ್ ಪಂಪ್ಸ್. ಸೊ ಇವಾಗ ಅದೇ ಝೋನ್ಸ್ ಅದೇ ಫ್ಲೋರ್ಸ್ ಅಲ್ಲಿ ಆಗುತ್ತೆ. ಸೊ ಸ್ಪ್ರಿಂಕ್ಲರ್ ಅಂತ ಬಂದ್ರೆ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಏರಿಯಾನ ಮೀಟ್ ಮಾಡಿದ್ರೆ ಸಾಕು. ನಾಟ್ ಎವ್ರಿವೇರ್ ದ ಫೈರ್ ಹ್ಯಾಪನ್ಸ್, ರೈಟ್? ಅಂದ್ರೆ ಅಟ್ ಎ ಟೈಮ್ ಅಲ್ಲಿ
ಏನಾಗುತ್ತೆ, 30 ಫ್ಲೋರ್ ಎಲ್ಲ ಹೋದಾಗ ಪ್ರೆಷರ್ ಹಂಗೆ ಇರುತ್ತೆ, ಹೆವಿ ಇರುತ್ತೆ ಪ್ರೆಷರ್. ಸೊ ಹೆಂಗೆ ಅದನ್ನ ಕ್ಯಾಟರ್ ಮಾಡ್ತಾರೆ ಅಂತ ಏನಾದ್ರು ನಮ್ ತರ
ವರ್ಟಿಕಲಿ, ರೈಟ್?
ವರ್ಟಿಕಲ್ ಶಾಫ್ಟ್ ಅಲ್ಲಿ
Mm.
Yeah, sorry. Please tell me. Will continue. Yes. Sorry, you were discussing something, Haley.
Sir, that's what we were discussing is that in the shaft, sir, when it comes to 30 floors, right?
Hmm.
Usually what we do in our plumbing system,
If you have, yeah, if you have the plumbing system, you might create like very high buildings in intermediate floor. Also, you could use as a you can have a sump and then you will recirculate it, right?
no, no, we will do zonings for the reduction of the pressure to get the minimal pressure at the end point. So in the same way, now we are designing these sprinklers, right? Based on my hazards and the square meter, we are designing our sprinklers, right? So
Right.
when it reaches the 30th floor, my pressure will be high in the vertical line.
Uh, no, not at the 30th floor. You might not have. At lower floor, you might have a higher thing. You
Yes,
might
yes.
have a very high pressure. So in that
Yes. So,
cases, we'll go for a your orifice plate. So in below floor level, at the main branches or anything, you can go for orifice plate, which will reduce the like a pressure reducing valve.
Okay.
You can use the orifice plate to reduce the pressure, and then you can do it. So at multiple locations, we'll provide a orifice plate.
That is to the branch, is it? Not for the vertical.
Not to the vertical, to the main branch will provide it. Of course, if that's, for example, if this is the entire zone, let's say you feel that the pressure at this location is higher, then here also you can provide it. It's up to you. There's no rule that you should not provide.
Okay. You will be using two vertical pipes in a shaft for sprinkler. Two vertical pipes. Like if you see a plan of a shaft,
Uh,
as of when you explained, there was
See,
idling.
nothing. See, if you have a 30 floor building, generally it'll never be so narrow, right? You'll have a very big building. You'll have a huge space. So anyway, you have for every 30 meters or every 45 meters, you have a shaft for your fire exit staircases. Alva.
ಹೌದು ಹೌದು.
So if not from one other zone, see one the few floors, if you use from one, from few floors you will use another one.
Okay.
But it's not that mandatory you should not have because there's no rule which says that you shouldn't have two headers in the sprinkler, single this thing. As I've shown an example, you could have that as well.
Understood. So you'll have one vertical. If the pressure exceeds, then you'll have a branch orifice plate. Not required to
Yes,
have.
you can install a orifice place to maintain the pressure. Yes.
and sir, one more thing in this FHA shaft, sir.
Hmm.
Uh, Usually, what will be the piping arrangements, sir? Means the size of the shaft.
Okay, that is around 1.2 meters by 1.8 meters is comfortable.
1.2 by 1.5.
Yeah, yeah. 1.2 by 1.8.
What will
1200 by 1800 if you have it. That will be comfortable for you.
okay? Then
You
what
can
about the
expand,
door size?
you can keep your what do you call your internal box also you can keep it inside only in this case.
Okay.
Yeah.
What if I don't have space to keep that inside the shaft?
Then you already exposed the hose reel cabinet. What else are you left with?
Okay.
You keep external your hose reel cabinet will be exposed. That's all. So
Oh,
after all, how much do you require? One hydrant pipe you require, Alva? That
yeah,
is how much
yes, sir.
diameter it is.
It's of around 150, 100.
Diameter will be 150 max.
Yes, sir.
And you require one more pipe, which is your sprinkler pipe.
Yeah,
You will require
yes.
one more drain line. Three
Drain line,
pipes you
yes.
ಬೇಕಷ್ಟೇ ಅಲ್ವಾ in and ಬೇಕು.
Okay.
So if the pipes, let's say you have a very small shaft, we'll
Hmm.
keep every bloody thing exposed. So your hydrant well could come here or you take it outside. It's up to you if the shaft size is smaller. If you want to
Okay.
conceal
If
everything, then
I
1.2 by 1.8 is comfortable. That's it.
yeah, if I take the wetrizer inside the shaft and this cabinet outside, from shaft to this cabinet, can I connect it, right? But it will be exposed.
Your cabinet, why will you connect it in the first place? Your host rail drum, yes, there'll
No,
be a
no, how
connection.
will
But
you?
why will you have a like in a cabinet? Cabinet
No,
inside
no.
the cabinet, you will just have external like pipes and hoses. ಅಷ್ಟೇ ಅಲ್ವಾ?
Okay, okay.
And that should be
The
within 3 meters of your hydrant valve, as per
okay.
norms. No pen and teachers. So that's the thing. Understood or not?
Yeah, got it, sir.
Clear? Okay. So these are the only so shaft as such, that is the size, but yeah, it depends on the site condition. It will be exposed in most of the cases as well, especially like warehouse buildings and all. So the aesthetics is not your major concern anyway. So yeah, we might not even create a shaft actually. We'll just leave the pipes exposed in that cases. Any other query? Hello.
No, Chaitanya, no.
No, sir.
Yes, sir.
Okay, perfect. So I'll share you a couple of projects of a high-rise buildings as well as the normal ones. You can definitely have any queries as such. Okay, I'll share you over WhatsApp. So any other specific queries will stop recording. With it? Huh?